Alright, calculus, here are the last several. Number 11, the question says, hey, here's an f function. I'm going to give you f prime. When does f have a point of inflection? So our goal here is when does f double prime change sign, right? So I only need to take one more derivative. So here's f double prime, 3x squared minus 4. And then I need to find a 0 so I can make a sign chart, right? So 0 equals 3x squared minus 4. This doesn't factor nicely, so I'm going to solve it the old-fashioned way. Add 4 and divide by 3. And then when I take the square root of both sides, I get square root of 4/3 equals x. And so I can split up that square root on the top and the bottom, so I just get 2 over square root of 3. And my inflection points would actually be plus or minus, but at this point I don't even need to make a sign chart because I see like that's my only option, that's my only answer choice, and it's definitely C. I could also say I know it's a polynomial, so I know it's going to go down and then come back up. Either way is fine with me, but definitely the only option there, 2 over root 3. Number 12, I love this question, that's why I put it on here straight from your homework. This was on 5.1 homework. No, not 5.1. 5.3 homework, I think. So the question says, on which of the following intervals are both of these things true? Now, when in my annotation, I'm going to say this means if the first derivative is positive, that means f is increasing. So where is it increasing? Let's go label that right now. I know my function is increasing from here to here. The second key piece of info, the second derivative is less than 0. That means my function is concave down. That's also from that table above. Where is this function concave down? I'm going to highlight this section here as well. It's concave down from here to here. So where are both of those true at the same time? Both of those are true between B and C. This is a free response on your homework, but actually it was taken from an AP test, so it's the multiple choice version, but B is your solution. Number 13, last multiple choice here. This one was a throwback, but it does apply to this unit still. It says which one could be f prime. So toss your zeros on and graph the derivative on top of this, and then tell me which one it looks most like. So these are my zeros, right? The slope is 0 right there, and right there, and right there, but I missed one. And then our next goal is in between each one, what is my function doing? So between here and here, my function is increasing, so my derivative is positive. Then my function is decreasing, so my derivative is negative. And then I increase on the right, I'm decreasing on the left. Which one does this look most like? Definitely A. That was a pretty solid question overall, nice job. Okay, 14 and 15 are the same kinds of questions. They're all the same kinds of questions, right? We're all using that same info from above. That's why a lot of you said, hey, what should I study? Like, study your 5.4 notes is what I told several of you. And those of you who did, awesome job. Number 14, though, 3 questions. Number 1, where is h increasing? So again, here's your key question. Where is it increasing? It's increasing wherever h prime is positive. So look at your table. Where is h prime positive? That's all I care about. Only from 3 to 5. So these are all x values on top. So I'm going to say it's increasing between 3 and 5 since h prime of x is greater than 0. That's all you need. B, local extrema or extrema. This is, where does my function change from at a minimum or at a maximum, right? Those only happen when h prime changes sign. So from -8 to -3 up here, my function's decreasing. Then it levels off a little bit, but then it decreases again. But then it's undefined, so there's a hole in the derivative. And then it's increasing. So the only extrema happens at, not h, at x equals 3, since h prime of x, it's h prime, changes sign. And is it a min or a max? What changes from negative to positive? And so it is a local min. Local min h prime changed from negative to positive. And I'm going to write all that out this time, but not next time. That should be your reasoning. H prime changes from negative to positive. I'm giving you H prime, so that's what we need to reference. And then where is there an inflection point? Where is the second derivative changing sign? So I'm going to say at x equals negative 3. H double prime of x changes from positive to negative, right? There we go, 6 out of 6. 2 points for each of those. 1 point for the answer, 1 point for the reason. And then the last one, number 15, this one was tricky also, but the same principles again. Where is there a critical point of g? That's where does g prime of x equal 0? This actually looks like it happens twice, right? It looks like it's here and here, but since the interval is open, that means I don't include 5. So yes, 5 is at 0, but we don't actually care about it here, so don't worry about 5. So that only means that x equals 0 is a critical point. And is it a relative to the max or neither? Well, it is a relative min because g prime was negative, and then 0, and then positive. So it's a relative min since g prime changed from negative to positive. I'm writing all these out because these are the reasons we should have for our solution. We can't get much shorter than this, and this is the key info we need. So I would encourage you to write out basically exactly this phrase, or at least this much info, because that's the reason we need, and it can't be much shorter. I skipped C because it wasn't actually relevant to what we know, but letter D says, is 2 a point of inflection? So this one I am going to scroll all the way up, because I want to show you the definition that you had on the screen. Points of inflection exist when f prime changes direction, or f double prime is 0 or undefined and changes sign. So I want you to go all the way back down here. Does f prime, or does g prime in this case, change direction at 2? Is it changing direction right there? Absolutely. Some of you tried to reference g double prime. We actually can only reference what we have. So since I have g prime, I need to reference g prime. If you drew your own g double prime, that's fine. But some of you didn't write it, or you didn't draw it, and then you tried to reference g double prime. We can't reference something that's not on our graph or given to us. So, does a point of inflection exist? Yes, since g prime changes from increasing to decreasing. That's all you need. How about 0? Am I changing direction? No. No. G prime is increasing on either side of 0. Letter F. Okay, F and G are throwbacks a little bit, but they're things you definitely know how to do. So first step, let's plug in negative 2. So G prime of negative 2. Luckily, we have G prime. So look at G prime. Here's negative 2. My output is negative 1. So I get, on top, I'm definitely going to get negative 1 plus 1. Oh crap, that's going to be 0. On the bottom, negative 2 squared, that's 4 minus 4. Well, crap, that's 0 over 0. So in our heads, we're thinking 0 over 0 means L'Hopital's rule. But the justification has to be better than this. So I'm going to leave this here as like some scratch work, but really our justification has to say the limit as x approaches negative 2 of g prime of x plus 1 equals 0, the limit as x approaches negative 2 of x squared minus 4 equals 0, so I can use L'Hopital's rule. That's one point. The second point is doing it. So let's take the derivative. So the limit as x approaches negative 2 of g double prime of x over 2x. Remember, if I take a derivative of g prime, I just add another prime. Which means, looking back up at my graph, if I have g prime, g double prime is just the slope. So the slope somewhere around here. And I can go up 1 and right 2. So my slope is 1/2. So coming back down here, g double prime is 1/2. If I plug in negative 2 on the bottom, I get negative 4. I can simplify by multiplying by the reciprocal. Some of you wrote this as 2. You multiplied by 4 instead of divided by 4. Our final answer should be negative 1/8. If you get to here, just stop. Don't simplify. That's all numbers. You can stop right there. If you feel confident about it, go for it. But like, if some of you missed this and you didn't need to because you just simplified wrong. Last one. I'm given h of x. You've seen this question many times, and you want h prime of 2. Take a derivative. Luckily, this is two things multiplied together, and so we know how to do the product rule. So h prime of x is 1 times g of x plus x times g prime of x. G of x is given to us. I'm going to plug in 2, right? So h prime of 2, 1 times, I'll write it all out here, g of 2 plus 2 times g prime of 2. I just plugged in 2 everywhere I saw an x. So thankfully they give us the g of 2 equals 6. Otherwise I would not know how to find that yet. So 6 plus 2 times g prime of 2, we'll look all the way back up at your chart. G prime of 2, I already had it circled, is 3. So 2 times 3, 6 plus 6 is 12. This question was worth 11 points, 1 for part A and then 2 for the rest of them. Again, you know all this stuff. You have the tools. It's just putting it together. We will keep practicing and you'll continue to get better. But if you don't study those Unit 5.5 notes, it's going to take a little bit longer to stick. So keep practicing that, keep looking that over. We will prep this today and Monday in class and get ready for that final. See you soon.